right. Now I would like for you to find the domain and the range of this function. So go ahead and select from the following multiple choice. What is the domain of this function and what is the range of this function? Remember that domain is all of your x values, all possible x values for this. And notice, you can look in your graph, we're not restricted. This graph will keep going all the way to the left, really slowly because it's going down a lot more than it's going to the left. And same with going to the right, it's going down more than it's going to the right, but it'll continue to go out and out and out for forever. So really, along the x-axis, we have no restrictions. So all real numbers. And you can say all real numbers, or we can do set notation x such that x exists in the real numbers, or you can do x such that negative infinity, x positive infinity. Yeah. So those are ways that you can write your domain. Range, however, with quadratics is restricted. There's either a maximum or a minimum. So there's at some point where it doesn't get higher or it doesn't get lower. So you need to figure out what that is. Range is your set of all of your y values such that, and realize that we have a maximum, which means that's the tallest it can get. So all of our y values are going to have to be that value or less. So it's y is less than or equal to 10.1. Or you could just do y less than or equal to 10.1. Okay. Find the equation of the axis of symmetry. So if you're struggling on to remember how to write the equation for the axis of symmetry, definitely look on the page before. So remember that the axis of symmetry is a vertical line. And the way to write an equation for a vertical line is x equals a number. That number is the x value of your vertex, which is helpful because we want to know more about our vertex. So if we know something about our axis of symmetry, then we know the x value of our vertex and we can figure more stuff out from there. So our axis of symmetry is, first of all, just x equals. And then you go to your vertex, hey, x value is 7.5. My axis of symmetry is x equals 7.5. And that's the equation. All right. The main thing that I really wanted to get to today is how we create models sometimes, the puzzling out of creating models. So a lot of times we'll be presented with something that looks like this: y equals ax squared plus bx plus c. A, b, and c are the parameters of your equation. So ax squared plus bx plus c. A, b, and c are your parameters of the equation. I like to call them the unknowns. You are supposed to have numbers in there. In order to define a specific parabola, you need to have numbers for that parabola, for those values. We always want a y, or f of x, and an x, right? If we didn't have an x, then we wouldn't have an input. If we didn't have an input, then it's not an equation. So we want to solve for a, b, and c in order to define that. We always still need an x and y value for our final equation. So when we go down and we have a problem like this is no context whatsoever. When you encounter this in an IB problem, it will be given to you in a context of, like, we know at time 0, we have -9 something. The height is at -9 from some arbitrary 0. 0 is the height of the building. -9 means it's 9 meters below the building. And then at -1, whatever that context is, it will give it to you in the context of that situation. But really what those mean is that it's a point. And so you can use points, which are x and y values. I'll call this x1, y1, and I'll call this x2, y2, that you can plug them in for x and y. So then that would be the first thing that you would want to approach when you're approaching a problem like this. If you see a point, or if you can create a point from the context that you're given, take those points and put them into this generic equation for a parabola. So you get started and you're like, okay, well, -9 equals a times, well, my x value for -9 is 0, but it's 0 squared, plus b times, okay, it's 0, and then plus c. So now what I've done is I've just created an equation that has 3 unknowns, a, b, and c. 0a, whoops, 0b, and then c. When I have three unknowns, in order to solve for those unknowns, I need to have three equations. That always matches up. So if your generic equation of a model has three unknowns, like a quadratic, then you need three equations that you can create for the situation in order to make a specific quadratic equation for that situation. If you have something like an equation of a line and your unknowns are mx plus b, m and b, you have two unknowns, which means you would need to make two equations like this in order to solve for those unknowns. Here is one equation. My other equation, so it actually becomes negative 9 equals c. So your c will always be your y-intercept. This is your y-intercept, right? When x equals 0. So your c is always your y-intercept. And so we already found what c is. Cool, awesome, 1 point for me in this challenging problem. And then I'm going to see, okay, well, what happens when I plug in the other point? Well, the other point has a y value of 9. 9 equals a times x, which is negative 1 squared, plus b times negative 1 plus c, which, hey, I know is negative 9, so I can make that minus 9. So that's 9 equals negative 1 squared is 1. B times negative 1 is negative b. I can add 9 to both sides. 18 equals a minus b. Okay. Now I have two unknowns. C I've already solved for, right? So now I'm just left with A and B. So I need to have two equations that deal with A and B in order for this to be solved. So I've plugged in the 2 points, which is two pieces of information that's been given to me. And then they give us the axis of symmetry. Okay, well, the axis of symmetry doesn't feel like it could be super helpful, except for the fact that we have an equation for the axis of symmetry. And the equation for the axis of symmetry is, x equals negative b over 2a. Okay, so x equals what for the axis of symmetry? It equals 4, right? So when x equals 4, I do 4 equals negative b over 2a. And now I have two equations here and here that involve my two unknowns, a and b. So now I have enough information that I can solve for those pieces. There are two ways that you can do this. The way, because this is a system of equations, right? So how can you solve? Elimination, substitution, or graphing. You can solve for them by substitution, isolating for one of the variables in either of these situations, plugging it in for the other, and solving. Or remember that your calculator has a system of equations operation that you can use. So if you go back to your calculate section, go to menu, and then you go to algebra, solve systems of linear equations. Since it is a system of linear equations, that means that you cannot have a nonlinear equation. Fraction functions are nonlinear equations. Equations that have an exponent are nonlinear equations. So you need to make sure that they're all linear. This is linear, right? I could multiply 2a or cross multiply, in other words, on both sides, and I get 8a equals negative b, which then would be an easy substitution over here, but that's beside the point. So when I go in here, I just replaced x and y down here with a and b. Sometimes this guy can be a little tricky because you press down and then it goes to 1 up here, but we want two equations, but keep scrolling over and figure it out, and you've got it. So then you can go ahead and put in your two equations. 18 equals a minus b. Remember, equals is right here. And 8a equals negative b. And then you go ahead and plug it in, and you get an answer. And I would like for you to go ahead and do that. So recap, either isolate, substitute in, solve for a and b, or menu, algebra, systems of linear equations. And then you can solve using that. So you should get that a equals 2 and b equals negative 16. You can see that if I went in and did 18 equals a minus b, and then 8a equals negative b, 2, and negative 16. A is negative, or A is 2, B is negative 16. This will happen a lot. This type of problem will happen a lot, but with a lot more context further on in this unit. So just being able to kind of figure out, I need to create a system of equations in order to solve for my unknowns is a big key step here in order to get further along in this unit. Good job today.